Factoring intervention round 2 of some more examples here, especially with greatest common factors, because that's what I've seen the biggest issue with. Number 1, 2x squared plus 6x plus 4, okay? The first thing you ask yourself is, what do they have in common? You look across the whole thing, they all have a 2 in common, so I'm going to factor out a 2. Factoring is kind of like saying division, okay? Like dividing, right? Like product and multiplication, sum and addition. Factoring, quotient, all that kind of stuff, you are kind of dividing. Question? Okay, cool. So I am dividing out a 2. What do they have in common? They have a 2 in common. So I have x squared, 2 divided by 2 is 1. X squared is just a 1. 6x divided by 2 is 3, and then 4 divided by 2 is 2. Cool, right? Step 1, greatest common factor, what do they have in common? Cool. Step 2 now is to actually factor. So I do my factor bundles, x and x. And now riddle time. Adds to get 3, multiplies to get 2. So now I always take this number and factor tree. 2, 1 times 2 is the only factor of 2. And sure enough, a 1 and a 2 can get a 3. So I have a 1 and a 2. I need to be able to get a positive 3 here, so it's going to be a 1 plus 2 is 3. 1 times 2 is 2. Check, boom, we're good. There's the first one. Cool. Second one. I do want to do the second one because of how similar it is, but different at the same time. We have 4a squared minus 12a plus 8. Okay? What do they have in common? Okay. Somebody last class said, oh, they have a 2 in common also. Do they have a 2 in common? They do have a 2 in common. They do. This is divisible by 2, this is divisible by 2, and this is divisible by 2. But is it the greatest common factor? No, 4 is the greatest common factor. Okay, that is important to know though. Okay, that's why it's called greatest common factor, right? So divided by 4, we have our a squared. Divided by 4, we have minus 3a. Divided by 4, we have plus 2. What do you notice? Oh my God, it's like super similar, and I'm purposely doing that because we have 4 factor bundles, a and a. 2, oh my gosh, it's like the same thing. Factors of 2 was 1 and 2, right? And they can get 3, 1 and 2. But now what's going to happen? They're both. They're both negative because a 1 and a 2, 1 plus 2 is 3, yes. 1 and 2 can get a negative 3, but they both are negative now. So very similar, but they are negative. That's your answer. And negative times a negative is still positive, so it works out. Okay, check all those spots. All right. Now, I really like this one, number 7. Okay, that's going to look a little different. We have x to the 4th minus 15x cubed plus 56x squared. What's the biggest thing you see here that's like, whoa, that's different? There should be a red flag that goes off. The exponents are not what they're supposed to be, right? That's a tip. I learned this tip this year after 10 years of teaching math. A lot of times you guys are like, how do you know where to start? Like, how do you know what to do at the beginning? How do you know whatever's going on, okay? Know what it's supposed to look like, and then what it's different. So that's why I try and point out these red flags and stuff here. What is this supposed to be? X squared. It's supposed to be some amount of x squared. In fact, I'm going to write this right here. This is called standard form. Ax squared plus bx plus c. That is what it's supposed to look like, right? In a perfect world, that's what it's supposed to look like. So I see this, and you just know, I don't care about the 15, I don't care about the 56, the x's are wrong. Okay, so anyway, let's fix that. What do they have in common? They do have an x in common, but what's the greatest amount of x's that they all have? 2, yes. They all have 2 x's, okay? So I'm going to subtract them out now because exponents work differently. I'm going to subtract the exponents. So I have 4 x's minus 2 x's. I have 2 x's. Minus 15 because the numbers aren't being affected. I have 3 x's. I take away 2 x's. I have 1 x. Plus 56 because again the numbers is just 1. So that 56 divided by 1, that's not affected. I have 2 x's. Take away 2 x's, I have no x's. And now we're in the spot where we purposely wanted it to be in, of like kind of knowing a little hint as to where to start going with this thing. All right. So now I'm going to factor x squared, factor bundles, x and x. Cool. And that's basically this x squared being broken apart. If I've never said that before too, like x squared, x times x. Okay, anyway. So I'm doing my factor riddle. I got 56 right here. I got 56. 1 times 56 does not get me 15. 2 times 28 does not get me 15. You can do this on the calculator. 56 divided by 2, enter. 56 divided by 3, enter. 3 actually doesn't work. 4 works, and I think you get 14. Yeah. 4 and 14 is close. 4 and a 14 could add together to get me an 18, or they could subtract away from each other to get a 10. 14 minus 4, 10, right? So not a 15 though. I keep going. 5 doesn't work. 6 doesn't work. 7 times 8. Whew. Whew, finally. Okay. 7 and an 8 work. Okay. Now, I've never described it like this before, but this worked for last class, and I had a bunch of light bulbs click on. Literally, people, oh, okay. So say that again. So for the video, right? All right. So this might be a weird question. Are a 7 and an 8, are either of them bigger than a 15? No. Neither of them are bigger than a 15. So if they want to become a 15, what are the 7 and 8 going to have to do to be able to become a 15? They're going to have to join forces together. It sounds like a nerdy game example, but they have to join forces together on the same team to be able to become more than they would be separately. That's like a motivational thing right there, right? Together, okay. So 7 and 8 are not bigger than a 15. They have to join forces together, or together, the same sign is what I'm trying to get at here, to become more than what they are, right? So if they want to become a 15, they have to be together, same sign, but what are they trying to become? What kind of 15 are they trying to become? Ooh, a negative 15. They're trying to become a negative 15, so they got to both be like, okay, to be, like, imagine them both being 7 and 8. Like, all right, should we both be positive or should we both be negative? Oh, we got to both be negative. Okay, and then now they're good, and they hit it. And this also works out because negative 7 times negative 8 is a positive 56. Cool. And that's your answer. Okay, let's do one more. I want to do a more difficult one. In fact, I'm going to do one that has an equals thing on it. Let's do 17. Okay, so I have 5x squared minus 35x plus 60 equals 0. Okay, yeah.
If there's like a number that they all have in common, right? Mm-hmm. You bring it down, right? Uh-huh. And if they all have an x in common, then you would bring it down
at the same time. Yeah,
so
yeah.
You would bring the number and the x down.
But and then it'd be like a some number x, and then you would divide out the numbers and take away the x's. Basically, 2 birds with 1 stone. You're dividing the numbers and you're taking the x's. Dividing the numbers, taking the x's. Yeah. Good question. So they have a 5 in common. 5, taking it out, right? So I have x squared. 35 divided by 5 is negative 7x. 6 divided by 5 is a 12. Cool, equals 0. Okay. Factor, keep going. Factor bundles. X's and x's equals 0. Also, side note here, this equals 0 is not going to affect anything that you do today. If I asked you to solve using factoring, that's something I'm going to teach you later in a whole later video, later unit. But right now, we're just factoring and trying to simplify it all the way down. Have you heard in math, have you heard of the word expression? And have you heard of the word equation? So many people see those as the same thing. This is an expression. It's just a bunch of math stuff that you're saying in a line. You're just expressing yourself in math. Okay, cool. This is an equation. Why do you think they call it an equation? The equal sign. This is an equation. Okay, so make sure you can't solve an expression. There's no equal sign. This, you will be able to have an x equals answer, but we're not focusing on that right now. So anyway, focusing on this 12. I got 12. 1 times 12 cannot get me a 7. 2 times 6 cannot get me a 7. It's not looking good, guys. 3 times 4, oh, there we go. 3 and a 4 can get me a 7. 3 and a 4, neither are big enough to become a 7, but if they join forces together, on the same team, they could become a -7. This doesn't seem like a very good thing to aspire to. I want to be a -7. You should be a +7, guys. Anyway, so that's the answer. That's as far as I want you to go. Okay, so can you solve this? Yes, because we have an equal sign and we have these things. We can do some stuff here. Okay, but that's as far as I want you to get for today. I'll have a whole separate thing for that. Okay, yeah, boom, that's it.